When it comes to the area of coding or software engineering, there are many benefits to using the Python programming language. First off, it is a language with a very simplistic syntax, meaning you're not going to spend a whole lot trying to get up and running, learning and applying the language. However, one of the biggest benefits that the Python programming language has going for it is how it uses object-oriented programming through the implementation of Python classes. However, in this video, we're going to cover 5 areas of Python classes that will get you up and running and coding like a Python pro in no time. Now, those 5 things we're going to discuss in this video are how to declare a Python class, how to assign attributes to a Python class, how to create class methods, how to be able to perform class inheritance, to create a parent and child class relationship, and finally, some useful secret quote unquote methods that you might not know about initially, but that are definitely going to be very useful for you going forward. If you guys find this video helpful, make sure you smash that like button and subscribe. But now let's get right into it. Now, like I mentioned in the intro, the first thing we need to figure out is how do we actually instantiate a Python class? Well, if you're at all familiar with creating functions in the Python programming language, the concept is actually very similar. Namely, you lead with the keyword class, similar to how you lead with the function def keyword, followed by the name of your class, along with a very important other feature that we'll get to in a moment. So as I say all the time, there's no better teacher than just simply doing it. And so let's go ahead and come over to whatever terminal and feel free to follow along in whatever IDE you're coding around in. But in order to create a Python class, we first begin with this class keyword. And if you're using an IDE, you'll notice that typically this class keyword will be highlighted a different color. The next thing we do is provide the name of our class. And for the sake of this video, I'll go ahead and keep it simple and just call this my class. Now you'll notice that unlike a Python function, typically the first letter of each word within a class name is capitalized. It doesn't need to be this way, but this is typically the industry standard. The final thing we want to do within this line of declaring our class is similar to how we declare a Python function. We simply follow it all with a colon. And so now this is great. We have now declared our Python class. However, we need to be able to provide what we call an init method. And I like to think of this init method as an initialization method, meaning we are actually going to allow references to this class within itself. And so I know that's pretty complicated, but let's go ahead and just code this out and I'll explain as we go. Now this init method is going to be declared as follows. Normally, just like how we declare a function, we'll go ahead and use this def keyword followed by this double underscore init double underscore set of words, and then we will always provide a self argument to this init method. And let's just go ahead right now and just provide a pass keyword here just to make sure we don't error out our program. Now this init method here allows us to reference other attributes, which we will get into in just a moment. But for now, because this class doesn't have any attributes, this init method is a bit pointless. However, it is always a good idea to declare it should we want to assign attributes in the future to a class. Now that we have declared our class object, we can actually assign it to a variable, and we can do so simply by typing the my class name here and providing the open and closed set of parentheses to this my class name right here. And indeed, we have now just created an instance of the my class object. And just to test that indeed this instance exists, we can go ahead and print out the type of this class, and you'll notice that when we go ahead and run our file, that indeed this variable is of the type my class, because again, right, it's a my class object. Now, as I mentioned before, since we have an instance of our class, well, what does a class exactly allow us to do in Python? Now, there are many arguments as to the benefit of using classes. However, the one that I find in practice, why I find classes to be so useful, is that it is a very syntactically clean and efficient way to store data or reference data within your code. If your program is over 1,000 lines long and you have variables just declared all over the place, it's not exactly conducive to be able to create very efficient programs. And so as a result, classes actually allow us to store various data types that we call attributes. And so how do we exactly assign an attribute to a class? Well, that's a great question. Recall our init method in the section just prior to this one. The reason why we created it is that when we create an instance of this my class object, we can actually pass arguments to the class itself, similar to how we pass arguments to a Python function. And so just for the sake of this video, I'm going to go ahead and pass the argument word to my init method. And so what this is going to require now is when I create an instance of the my class object and assign it to a variable, within that initial open and closed set of parentheses, I'm going to have to provide a word argument to that class. Now, perhaps the next most important thing that we have to keep in mind is that we need somewhere to store this init method argument. As a result, we can store this argument in the following way. We will go ahead and indent beneath our init method here and use the keyword self.word equals word. Essentially what we were doing is we were assigning as an attribute this word argument supplied to the myClass object to the self.word attribute. And so if you want to think about this as like forever in time, this class method is always going to have. Now again, the best way to illustrate this is just by doing an example. And so if we go ahead and assign our myClass object to a myClass variable, recall, because we now have this keyword word argument within our init method, we need to go ahead and supply a word within this open and closed set of parentheses. Now, to ensure that we have properly stored this argument to an attribute within our class, we can go ahead and actually print out this attribute by supplying the name of the variable that the class is assigned to and referencing this attribute by using the dot character along with the name of the attribute we originally called it in the first place. And in our case, it is going to be word. And if we were to go ahead and actually run our program here, you'll notice that indeed, by referencing this class object, we can recall what was initially supplied as an argument to that class to begin with. And attributes can be really any number of different data types or even data structures, right? They could be lists, they could be dictionaries, they could be sets, they could be integers, floats, none types, booleans, whatever your heart desires. But suffice it to say that the beauty of object-oriented programming in Python is that it's a very clean and efficient way to store data within your code and to be able to reference it later on. Now, the third concept we're going to talk about are class methods. And we've actually already sort of hinted at this, right, with this init method here. In this case, it's just a very special example of a method, but realistically, you can create any type of different class method that your heart desires. Realistically, class methods are just functions of Python, and you create them in a very, very similar manner to how you would create a normal Python function. The only difference is that functions are actually stored within the class itself and can be referenced as such. And again, creating a class method is identical to declaring a Python function. And so for the sake of this video, let's go ahead and just do a very simple example here. You'll notice I've created a class method within the myClass object called print word n times with an argument of n. And if we were to go ahead and dissect this function, you'll notice that for the number that we supply here as an argument to our class method, it's going to print out the phrase the word is, and then it's going to actually reference back to our class attribute self.word, and it will print essentially, if I supplied the word hello again, it will say the word is hello n times. And you'll notice that in addition to just supplying the keyword n here, I actually also had to supply the keyword itself. And again, this is because we are allowing this method to access the class attribute that we had stored previously. Now, let's say we create a method that's not as dynamic and does not reference other class methods or class attributes. Well, we can actually use a very special decorator called the static method decorator to ensure that that function in particular, or rather that class method in particular, cannot reference other methods or attributes within the class. And so as an example of that, I've actually created a new method right here called print hello world, and we just simply print hello world a single time. And because it's not referencing another class method or another class attribute, we can go ahead and supply the static method decorator just to ensure that it's sort of like locked and can't reference anything else. Okay guys, great. And so let's go ahead and do another example here. So let's go ahead and create our myClass object again, supply the myClass class to that variable, and go ahead and use the word hello again. Well, similarly to how we reference class attributes, we can actually invoke class methods in the exact same manner. Namely, we supply the variable name, use the dot character, and then after the dot character, we go ahead and just simply type out the name of our function here. And you'll notice, right, PyCharm or whatever IDE you're probably using actually has the suggestions for the method stored within the class. And so we'll go ahead and then supply the number 5 to the print word n times argument. Now you'll notice that even though we have a self argument and an n argument up here, and so if I were to go ahead and run my function here, you'll notice that yes, indeed, we supplied the number 5 to our method, and 5 times the phrase the word is hello was printed out on our screen here, which is exactly what we would expect if we came back and looked up at our class method definition. Similarly, if we just wanted to check, we could go ahead and invoke the other method called print hello world. If we were to go ahead and run our script there, and let me just comment this out so we don't pollute our terminal, you'll notice that indeed we get the words hello and world printed out, which is exactly what we would expect if we came back up and looked at our method. Now, hopefully you guys are finding this video helpful and you guys are starting to learn more about Python classes. But if you want to go deeper into different concepts and more in-depth concepts concepts of the Python programming language, I've actually created an online course called Software Engineering in Python, which I'll link down in the description of this video below, where we have multiple modules taking you from not even knowing how to code at all by creating variables for the first time, all the way up to, as a capstone project, creating different classes and actually applying unit tests to those classes, functions, and methods, which sounds probably pretty complicated to the uninitiated, but trust me when I say are very useful concepts when you actually get a job in the software engineering realm. And additionally, to help you guys pass the Notorious Coding interview, I actually have a data structures and algorithms module releasing next month to help you guys in your preparation journey. The course is only $50. There's a 100% money back guarantee. You guys will get lifetime access because I will continuously release new modules as I can. Again, I'll link the course down in the description below. I highly encourage you guys to check it out. But for now, let's get right back to the video. Now, the fourth concept that's going to be very important and is slightly more advanced when it comes to object-oriented programming in the Python programming language is this concept of class inheritance. And essentially, as the name implies, it is actually possible to have a what we would call child class inherit certain properties, namely the attributes and class methods of another class, which we call the parent class. Now, I know this probably sounds extremely vague, and so the best way, in my opinion, to learn about class inheritance is just by looking at an example. And so if you look on your screen right now, I actually have created two classes here, one being a parent class, which I've called animal, and one being a subclass or child class that I've called dog. Now, you'll notice that there's nothing really new about these classes, right? We have our init methods, we have our init arguments, we have our attributes, right? The only quote unquote new things about any of these classes is actually the child class. And there are two things you're going to want to pay attention here. Number one, normally when we declare a class, we just simply follow the class name with the colon argument like so. However, if we want to perform class inheritance, or said another way, if we want a child class to inherit certain properties from the parent class, we actually have to pass the name of the parent class within the open and closed set of parentheses immediately following the name of our class, and here the name of the dog class. And you'll notice this is kind of similar to how we declare a function or any method, right? We're just simply supplying the parent class as an argument to the class name, if you want to think of it that way. The second important thing to keep in mind is notice that this parent class has a required attribute called num legs, or the number of legs of the animal. Well, in order to properly inherit all properties and attributes and methods of the parent class, we will also have to provide this argument to the child class in addition to any other class specific arguments. We have to use this complex syntax here called this super initialization method, right? Super being a reference to the parent class, or often called the superclass. And because we require this numleg argument in the parent class, we have to supply it to the superclass init method as such, which again we pass to the child class init method right here with this argument. And then I have this additional argument here called attitude, and we can just assign it to an attribute as follows. And so hopefully you guys can see here, right? Our animal class allows our dog class to actually reference the sleeping and eating methods, but this dog class has a specific speak method that is not present within the animal class. And this concept is typically called extending a class, right? We are simply adding additional methods that weren't present in the parent class, but that will be present in the child class. And so again, there's really no better way than to learn by an example. And so let's go ahead and just take a look at what can happen here when we start assigning these classes to different types of variables. So you'll notice here that I now have assigned my animal class to a variable called animal. I've supplied the numlegs argument to the animal class because it is required back up here. And if I were to go ahead and run my script, you'll notice that indeed when calling the sleeping and eating methods, we get the I'm sleeping and I'm eating sentences to be printed out. Now, perhaps what's even more interesting is when we should declare an instance of the dog class. You'll notice that because our parent class, again, requires this numlegs argument, we have to supply that first to our dog class before anything else, but then we can go ahead and supply any other class specific arguments such as attitude, which again, right, is not present within the parent class. And just to be able to show you guys, right, we can actually reference the sleeping and eating method within the parent class as so, but we can also reference any class specific methods such as the speak one right here. And if I were to go ahead and run my program, indeed we get the sentences I'm eating and I'm sleeping from the parent class to be printed out appropriately, and then the speak method to be printed out, which is a class specific method for the dog class. Now, before we wrap this video up, I just want to go ahead and point out some really cool techniques. And these two techniques are as follows. First, let's say I have a class here called a test class, and I supply the arguments item1, item2, and item3 to their self.item1, item2, and item3 attributes respectively. Well, when we create an instance of this class, you'll notice that I can actually iterate over the attributes of this class using this dot__dict__ method. And typically methods with double underscores are called dunders. So for the sake of brevity, I can call this a dunderdict method. Essentially, what this dunder method allows me to do is return all attributes and assign values as a dictionary to whatever script I am running. And so, for instance, you guys will notice that I can go ahead and actually iterate over these attributes using the typical for key value in a dictionary.items method. And just let me go ahead and just comment this out because we'll talk about this in a second. But if I were to go ahead and run my script, you guys will notice that indeed, right, item1, which is going to be the name of our attribute, is assigned the value apple. Similarly, item2 is assigned the value banana, and item3 is assigned the value pear. So this dunderdict method is actually very useful if you ever want to iterate over the attributes of your class, or simply check out, hey, what's the value assigned to this class attribute. Now, finally, the last useful like dunder combination we can do is to get the actual name of our class to be printed out in our terminal. And you'll notice that if we assign a instance of a class to a variable, we can actually get that name back by using the underscore class dunder along with the underscore name dunder. And if we go ahead and print this value out, we can actually get the name of our class returned to us as a string. So something that's very useful if you guys are using like multiple classes within a script and never want to check, hey, what's the name of this variable, or rather what's the name of this class assigned to this variable in my script. That's gonna do it for this video, you guys. Hopefully it is now much easier interacting with this concept of Python classes within the Python programming language. Again, object-oriented programming is such a thing to get used to, especially if you want to learn other object-oriented based programming languages such as Java. Again, if you guys want to dive deeper into the concept of Python classes, I've linked down in the description below this video the link to the website for my online software engineering in Python course. If you guys found this video helpful, again, I'd really appreciate it if you just left me a like, subscribe, comment below if there are any other tutorials you want to see in the future. But again, thank you guys all so much for watching, and I will catch you in the next one. Later.